Hi, my name is Farida Abdullah, and in today's video you are going to learn about the Earth's components, how a volcano erupts, as well as igneous rock. So stay tuned. Let us start with the layers of the Earth. The first layer of the Earth is the crust. You get two types of crust: oceanic crust and continental crust. The continental crust includes mountains, mountain ridges, and what we live on. And the oceanic crust is the ocean. However, the oceanic crust is less thicker than the continental. The continental crust ranges between 30 kilometers to 70, whereas the oceanic is about 5 kilometers thick. Okay, let us see the properties of the crust. The crust is solid. It's brittle in nature because it causes a fault. Therefore, earthquakes happened, volcanoes, and other disruptions in the earth. Now we move on to the mantle. The mantle is the thickest layer of the earth. The upper mantle consists of the asthenosphere. Asthenosphere means weak. And this is where we find our magma. The magma, which we'll talk about later, is the cause of a volcano. Right. Then we have the asthenosphere together with the crust make up the lithosphere. Now we go on to the lower part of the mantle. Basically, the mantle produces semantic waves and seismic waves. The molten rock is part of the mantle, which is magma. It is fluid and can move, which powers the movement of tectonic plates. So the flow in the mantle causes the tectonic plates to move. And if these plates collide, which cause earthquakes. Now we can move on to the outer core. The outer core is a liquid state which consists of iron and nickel. So an easy way to remember the core is called the knife layer. Ni stands for nickel and Fe stands for iron, if we check it up on the periodic table. The outer core is liquid, which also powers the magnetic field. The movement of the outer core, the movement of the liquid in the outer core powers the magnetic field. And without the magnetic field, asteroids would collide into our Earth and many other disruptions to the Earth. Then we move on to the inner core. Now the inner core is the smallest layer of the Earth, as we can see, and it also contains iron and nickel, which is part of the knife layer. It is solid, and the temperature is almost like the sun's temperature. It's extremely hot. And of course, it has the highest density. Now, if we look at all of the layers, the density increases. So the lowest density would be the crust, which floats on top of the mantle. Then it's the mantle, the outer core, and the inner core, of course. Density decreases. Right, here's a side note about magma. Now we know magma has less density. There we go. It has less density compared to the rocks around it. So magma floats to the top. And magma seeks out cracks to flow in which to form magma chambers. So it's, for example, a tap running. Now the water will run through and there'll be small cracks along the way. And that is how the water flows. So if I have water flowing through and I have a pavement with small tiny cracks, obviously the water will flow through there, much like how magma would. Magma will float to the top. It will look for tiny cracks, and then it will form magma chambers. Now the magma only erupts when these conditions are met. When there's extreme pressure, change in heat, and movement of tectonic plates. Okay, now we move on to the volcano. So as you can see, here's a 2D diagram of a cross-section of a volcano. Here we have our magma, which is in the mantle, M for magma, M for mantle. Easy way to remember. Now, here we have a long throat. This is the throat. And we have channels which reach the surface and spew out lava. Magma is when magma is inside the volcano, and when it's spewed out, it's known as lava. Now, this is our ash cloud. This is our ash cloud. Now, the ash cloud causes a lot of fog into the air and air pollution. That is why when there's a volcano, all the aeroplanes stop flying because of the huge ash cloud it covers. Okay, so that's the ash cloud. Now we move on to how the volcano erupts. So if we look at point 1, molten rock, known as magma, rises to the surface. So let's go. Molten rock magma rises to the surface, and magma forms when the mantle melts. So when it gets really hot in the mantle, then magma flows to the surface. And that's when pressure is increased, because an increase in temperature is an increase in pressure. Right. If magma is thick, gas bubbles can not escape. So magma is thick and the gas bubbles are stuck together, so it cannot escape. And pressure increases even further. Therefore, magma rises to the surface. And when the pressure is too high, an eruption can happen. So, for example, if you take a Coke bottle and you shake it, and then when you even open just a little bit of the cap, you'll see that so much of pressure was inside of those gas bubbles that they start spewing out, even though you haven't opened the Coke bottle completely. So that's the concept behind pressure. So basically, this is how the volcano erupts. Now, once the lava is reached the surface, it solidifies and is known as igneous rocks. So it starts off, this is the cycle. It starts off as magma, which is inside the volcano. Then it moves on and it's spewed out as lava. Then it transfers. When it solidifies and hardens and cools, it becomes igneous rock. Right. Now, there are many types of igneous rocks, and we will just concentrate on these 3 for now. So we have granite, pumice, and obsidian. Alright, let's start off with granite. So granite, here's granite. So it is coarse grained. It's light colored. It can be light or dark colored. It consists of quartz. Right, here's it here. I don't know if you can see the small crystals. It's coarse grained if you feel it. Okay, it consists of quartz, feldspar, and mica minerals. Now we move on to pumice. Here we go. Here's pumice. Right. Sorry. Okay, there's pumice. Pumice is a rough texture. It's light colored, low density. It can float. If something has low density, it means it can float. And the common use is in foot spas to scrub off the dead skin off your feet. Okay, then we have obsidian. Obsidian, when you think of obsidian, you should think of glass. So it's glass-like, it's smooth. It's usually blackish or green. And it's dark colored. So it's very smooth if you feel it. Yeah. Okay, and you get many other igneous rock. Here's another example, basalt, which is smooth, like this one here. And yeah, these are the types of rocks. Okay, for your solution, we're going to use bicarbonate of soda, which is a base. We're just going to add a few tablespoons into the mixture. Okay, just going to add, it's okay if it messes, just going to add a little bit. This is our base, and then for our solution, we're going to take a cup, we're going to take some dishwashing liquid, and our acid, some vinegar. Just going to pour that up. And for the red color, we're going to use some food coloring. Just a little bit of that. And we're going to mix our solution. And now, watch how it's going to erupt. Okay, it should erupt. Okay, and we see that lovely flow of lava. Isn't that so cool? Thank you for watching, and I hope you have learned something and gained some knowledge. So let us go over what we learned today. We learned about the layers of the earth, which are the crust, the mantle, and the core, the outer core and the inner core. Then we learned about how a volcano erupts. We learned that magma reaches the surface of high temperatures, high pressure, and it's eventually spewed out through channels. And when that lava solidifies, then it becomes igneous rock. And we know we learned the three types of rock: granite, pumice, and obsidian. Thank you so much again for watching. Please let me know if you have any comments, questions, or concerns. You can leave that down below. And thank you again for watching. Have a great day.